So today I found the solution to good code in Python. My name is Andrew. Let me show you what I mean by that. I'm a Python programmer. My name is Andrew, and today I created a library called PyAssimilator. So PyAssimilator allows you to write the best Python patterns in a very short amount of time with no dependencies whatsoever. So let me just show you what I mean. Just hang on. You are probably going to use patterns. So pattern, design pattern, unique Python pattern, domain-driven design pattern, and so on and so on and so on. But there is one problem with patterns. Some of the patterns that you're going to use are not suitable for all of the applications that you're going to write. So there may be some function that is not usable for that specific case. There may be some pattern that kind of useful, but not really, because it doesn't work in that specific setting. And that's why I created PyAssimilator. Aside from that, if you want to use patterns, you need to write them yourself. And that's a lot of time, a lot of work, a lot of bugs, and so on and so on and so on. So let me just show you why you need Assimilator in your Python projects. First of all, that library mainly produces domain-driven design patterns. Let's look at the idea of that library. So let's say that we have a program. So here's my program. You can find it in the GitHub in the examples folder. And that program allows you to create users, read users, update users, and so on and so on and so on. All of the users are stored in the database. And let's say that I want to start with SQL Alchemy. So relational databases, SQL, all that stuff. If I want to start with SQL Alchemy, what do? I create SQL Alchemy patterns. I write my code. So let's see, create user quarks with UOV. So we start a transaction with a pattern called unit of work. We save our user and so on and so on and so on. So that's just basic stuff, right? We just run our program and everything works, because that's an example that I created beforehand. So yeah, after a short delay with the connection, we can see that user was created, user was updated, user has some kind of balance, users were deleted, we counted our users, and so on and so on and so on. But here's the thing. Let's say that you want to switch your SQL Alchemy to MongoDB. MongoDB, no SQL database. Here's what you have to do if you don't use PyAssimilator. You spend 20 hours of your time, you spend 2 days of your time, you spend 50 days of your time, you spend 2 months, 1 year on rewriting your whole project. Here's what you do with Assimilator. You go do your code, you just change your patterns, you run it again, and everything works perfectly fine, as you can see it right here. So what's the idea with Assimilator? It allows you to write code in such a way that you have no dependencies whatsoever. So that code, I did not change the files. That's the same file main.py, but the code is not, well, the code is the same, but the patterns are different. So the only thing that I did is I replaced one object with another. And that's it. That's how you go from Alchemy to MongoDB. That's how you go from SQL to NoSQL. Then let's say you want to go from MongoDB to Python dictionaries. Here's what you do. You just change your configuration to internal. So internal objects, Python dictionaries. And everything is the same. As you can see, all the operations like filter a user, use regex, so regular expression on a user, update a user, delete a user, work with dictionaries, MongoDB, SQL Alchemy, Redis, and whatever you want. So you can easily create your own patterns, you can easily create your own data sources. But here's the thing, you don't really need to change any of your code if you write everything in Assimilator. So as you can see, I do not change any of my code in order to switch from internal to SQL Alchemy, from SQL Alchemy to Redis, and so on and so on and so on. So we have no dependencies whatsoever. And when I say no dependencies, I do not mean dependencies from a library. I mean dependencies from a data storage. That's pretty cool. Aside from that, let's say that your application is really complex. So you have some sort of a scientific application and you want to use a simulator. And you really need that specific feature that is only found in one library. Let's say in Redis. So you need that specific feature from Redis. What you can do is you can just use your specific features from Redis. There is another way of writing your code when you really use specific features from Redis. As you can see here from MongoDB, we use a dictionary with MongoDB filters. We use normal SQL Alchemy filters, normal SQL Alchemy joins, and so on and so on and so on. So here's an idea. You can write your code in such a way that you have no dependencies whatsoever. You use the best patterns, which are very simple. So as you can see, with UOV, repository save, we save a user. We read the user, we update the user. That is really simple. Aside from that, if you want, even if you want, you can use some dependencies and you can do something that is that can only be done with one specific library. And aside from that, that is really, really, really fast. So you can write all of that code in like 20, maybe 15 minutes, and it's gonna create, update, delete, and do all sorts of stuff with your users. You can switch between different data storages, you can use different patterns, and you can do that in a very, very, very short period of time. That is Assimilator, and that's what I created. Again, that's not all of it, and that sounds simple, but it's not always is. So if you want to know more about Assimilator, and you should know more about Assimilator, because that library is going to be everywhere in like a year, what you can do is you can go to documentation, link is in the description, and start from the concepts to basic tutorials to other things like SQL Alchemy, Internal, Redis, and well, MongoDB is going to be there as well. And you're going to learn everything that you need to know about Assimilator. And of course, even if you have any kind of problem, you can just open a discussion, you can open a pull request, or you can just write a comment in that video or on that video, so down below. My name is Andrew, thank you for watching, and bye bye.